Alright, boys and girls, I'm going to go quickly through the 25-point quiz that you guys just took. And I'm using someone else's paper, but I'm going to go through which questions are right, which questions are wrong. Just kind of follow along and pause it when you want to kind of stop and check your own work. So the answers to 1A through D are pretty self-explanatory. You can pretty much just see what the answers are. The only mistake I really found was C, where it says people forgot to put the if and only if in the middle. So I'm at Westland Middle School if and only if I live in Bethesda. And last, you know that it's not a definition, but the major reason is that the converse is not true. If you are in Bethesda, then you are at Westland Middle School is an incorrect statement, because the counterexample would be you could be in Bethesda and you could be somewhere else other than Westland Middle School. You could be at the movies. So let's get down to number 2. Most students were able to write the conditional and the converse correctly. What they missed is the conditional. If x squared equals 9, then x equals 3. That's actually a false statement, because let's say x was equal to negative 3. Well, you could still have this part. If x squared, so if negative 3 squared equals 9, but this part would then be false, because x wouldn't equal 3, x actually equals negative 3. So x being a negative 3 is a counterexample for the conditional statement. Now the converse statement, if x equals 3, then x squared equals 9, that is actually true, because when you square the number 3, you always will get 9. This was a little bit of a concern, only because, so when you make an Euler diagram, so you're going to represent all the following. Geometry students are happy, so that would look like this. This one right here. If you represent that all geometry students are happy, that means if you're a geometry student, you have to be happy. So the correct answer would have looked like this. This is actually the conditional statement. Okay, you didn't really need this one. So this shows that being a geometry student, there's no other way than to be happy. Now, it says place a point in the Euler diagram where someone who is an algebra student and is happy. Well, that would be away from the geometry student, right here. You could have even labeled it algebra student, because you wouldn't be represented in geometry students, but you're still in the universe of being happy. So that's the first 3. Here's the next one. These are the correct answers. I'll just go through, why. Obviously, it says right here that it is the bisector, so we know that the first reason will be given. Now, as soon as the only thing that you said after saying it's the bisector was that 1 and 2 are congruent. Well, why can we say that? Well, we've just said that it's the bisector, and that is the definition of a bisector, the fact that 1 and 2 are going to be congruent. 1 is congruent to 3 is right here. That would be a given statement. And last, you have 2 congruent to 1, then 1 congruent to 3, and then you're bringing the beginning back to the end. And if you could almost write that as a logical chain. 2 goes to 1, the next one starts with 1, which goes to 3, and then you're bringing back the 2 originals. Well, you are kind of substituting, but we talked about in class that when it goes in this order and the numbers flow like they do, that's actually the transitive property, which in your notes, the transitive property is if A equals B and B equals C, then A equals C. You can see how one thing flows directly into the other, just like it does here. So that would be the transitive property. Next one was a proof. So first of all, A, B, and X, Y are given. So right here, we're taking this line, and the only thing that changed was that we were adding CD to both sides. So that's the addition property of equality. This was listed as given. And AB plus CD equals 9. So it looks like right here we have AB equal to XY. So it looks like we're substituting in AB for XY, but we're leaving the CD. So that is substitution. We're taking something and substituting it in. Now, angle 1 and angle 2 both form a line. That's a given. So if the measure of angle 1 equals 180 degrees, that is a definition of a line, because we've said that they form a line, and all lines are going to form 180 degrees. The measure of angle 2 is also 180 degrees. That is, a definition of a line. And then last, you have 1 equal to 180, 2 equal to 180, and then we're just substituting this into the 180 in the other line. So that would be the substitution property. next problem. The work shown. So basically, if AB equals 2x plus 3, so that's this right here, and we know AB is congruent to CD, so I'm going to put a line in there. Now, once you know that those are congruent, then we talked about in class that you know the overlapping segments, A to C, and B to D, are also congruent. And then right here, it actually gives us AC and BD as algebraic expressions. So since we knew that AB and CD were equal, we didn't actually really even need 2x plus 3 because we're going to set 10x minus 14 equal to 7x plus 4/10. And you can see the work right here will end up with x being equal to 4 8/10. And then when you plug it into CD, CD, remember, would be what AB and CD are going to have to be equal, so you can use 2x plus 3. But instead of x, we found out that x is 4 8/10. To solve it, you get 12 6/10. So this was the one that gave a lot of people problems. This was the challenge one, so I'm going to go ahead and do this one. So this all has to do with the overlapping segments theorem. Now, the first thing you know is that the whole thing equals 416. The next thing you know is that AC and BD are congruent. Now, those are overlapping segments. Now, if you forget about this little part right here, just look at from A to D. If AC is congruent to BD, then that would automatically mean the smaller segments are congruent. That's the overlapping segments theorem. We found the overlapping ones are congruent, so the smaller ones are congruent. Also, AD is congruent is equal to BE. Now let's look at AD. AD goes all the way over here, and BE goes all the way over there. Well, let's look at that, what that would look like if you took out, just use the ones we were talking about. A to D is congruent to BD. Notice I took the C out. It's fine that we took the C out because we're still talking about the same points. But what we just did there was we noticed that the overlapping segments were congruent, which then automatically make AB congruent to DE. So not only is CD congruent to AB, but DE is as well. So now we know that all of these are congruent, and the information it gives us is that BC is one more than twice CD. Well, I don't know anything about CD, so in algebra last year we learned that if we don't know anything about it, we're going to give it an x. Well, the cool thing is if this is x, that means that's x, and that means that is also x. So they're all equal. And instead of saying 2 times CD, I can call BC 2 times x plus 1. And then it gives us that the whole thing is 416. So the equation I can write and solve is if I add up all these, I'm going to add the x's, plus the 2x plus 1, it's going to equal 416. And then if you solve this, so you end up with 5x plus 1 equals 416, you could find out exactly what x is, and then you have this segment, that segment, that segment, and then you do 2 times x plus 1 to get that segment. This one, the first thing when we talked about conditionals, we learned that the hypothesis is the if part, the first sentence, so that would be the hypothesis. And then it is a cat would be the conclusion. So here, if you look at this picture, you can see that anytime you're a dolphin, you have to be a mammal. So one thing you could have said was all dolphins are mammals. You could have also said if you are a dolphin, then you are a mammal. But the fact of the matter is that the dolphins would be the if part, because then you would know you have to be a mammal, because every dolphin is contained in the mammal circle. Last one, it says given. So the only thing that's given right here are these lines. So this is what you would have written down in A. For B, it says substitution. So, you know, we went for 1 and 2 are supplementary, 2 and 3 are supplementary. Then we said that each of these equal 180. Well, what would I be substituting? This is the only line I really have. And I can see 2 things equal 180. So what you wanted to do for B was set them the measure of angle 1 plus the measure of angle 2, I'm going to then substitute this line in for the 180. And that's how we can set them equal. The measure of angle 3. Line number 5, or I'm sorry, line C, would be you went from, so remember we said that this is the reflexive property because you said 2 equals 2. And then if you look in the line above that, which is right here, you have a 2 on both sides, and then all of a sudden, you don't have a 2 anymore. It's because you subtracted the same thing from both sides, and you were left with 1 is 3. So that would be the subtraction property, because you subtracted 2 from both sides, property of equality. And the last one is, well, whatever you're trying to prove is always the last line, the last statement. So after you said angle 1 is equal to angle 3, you would say angle 1 is congruent to angle 3. Even if you didn't know anything else, you know that the last line is always what you're trying to prove. And that is the quiz.